So in the next agenda item, we will be hearing from several collaborators on the FRESSCA-Mujeres project. Ileana Navarro, Policy Associate at the Central California Environmental Justice Network. Dr. Mohammad, Heidarinejad, an assistant professor in the Department of Civil, Architectural, and Environmental Engineering at the Illinois Institute of Technology, and Stephanie Jarmul, Chief of the Safer Alternatives Assessment and Biomonitoring section at OEHHA. So today they will give a joint presentation on the results and impacts of the FRESSCA-Mujeres study.
Thank you, Amy. And I'll just briefly give an overview. If it's gonna work. There we go. So Ileana is going to be giving a study background. Ileana is attending online, so there she is. And then Mohammad will be providing an intervention analysis for the PM data. I will be giving the biomonitoring results, and then I'll pass it back over to Ileana, who will discuss the FRESSCA community impacts and perspectives and some next steps for the project. And with that, I'll turn it over to Ileana.
Hi, everyone. My name is Ileana with the Central California Environmental Justice Network, or CCJ, and as Stephanie mentioned. Thank you so much for having me today. I'm super excited to share about this study and share those community impacts that we feel were very impactful. To start off, well, agricultural workers in California's San Joaquin Valley, they face this critical health challenge of spending super long hours working outdoors and then having to return to home without the proper air filtration. And this has left them disproportionately exposed to wildfire smoke. And these exposures include wildfires, but also dust and smoke from agricultural fields and emissions from oil and gas operations. And I have here some photos taken from community members of their exposures. Many low-income families here also rely on evaporative coolers or storm coolers, which are the more affordable alternatives to air conditioners. And these systems, they pull in massive amounts of unfiltered outdoor air. And then when the wildfires smoke, when there's wildfires, the smoke with the extreme heat hit simultaneously, and these homes become super hazardous. And this is what led us to launching the FRESSCA-Mujeres and the FRESSCA project. Next slide. I'm going to be sharing with you all some videos from the community members that had the opportunity to record their experience through a community workshop led by Story Center. And this here is Erika's story.
Mi nombre es Erika Montejano. Vivo en Coalinga, California. Nací en Jalisco, pero fui criada en Michoacán. Tengo 4 hijos varoncitos. Soy una persona muy alegre, pero hemos luchado mucho con la salud de nuestra familia. Con mi niño de 9 años duré mucho tiempo para embarazarme. Durante mi embarazo duré mucho tiempo sin caminar y anduve en silla de ruedas. Cuando él nació tenía un riñón más grande que el otro. Se enfermaba muy fácilmente. No se puede describir lo que una madre siente al ver a su hijo tirado en la cama. Uno como madre prefiere estar en el lugar de su hijo. Al verlos jugar, sonreír, divertirse, ver cómo se ponen los zapatos al revés y las calcetas volteadas. Durante un tiempo fue muy difícil. De hecho, no podía hablar mucho tiempo porque me ahogaba. Me daba tos, me dolía la cabeza. Nosotros estamos luchando con un gran monstruo. La mala calidad del aire es un asesino silencioso. Respiramos el humo de los incendios. Aquí cerca hay un lugar donde hay vacas. Huele muy feo.
We're going to pause it really quick right here just to continue talking more about this study, but we'll come back to this video at the end. Next slide. The goal of the FRESCA project, was to address this need by developing an affordable filtration intervention for homes with swamp coolers. We also then built on this project and launched FRESSCA-Mujeres, which aimed to evaluate the effectiveness of the air filtration interventions at reducing in-home exposures and learn more about female agriculture workers' exposures to air pollution, specifically in the valley. And we recruited from Fresno, Kings, and Kern counties. This slide was presented by Jeff Wagner at last November's meeting, but just as a brief reminder, we have 3 funding sources and many interdisciplinary partners on the full study team, which included folks involved in FRESCA and FRESCA-Mujeres. And then before Mohammad and Stephanie go into details about the results, we wanted to provide a brief overview of the study components. The FRESCA pilot project was conducted in 2022, and during that phase, we enrolled 25 homes from Kern and Fresno counties. We developed indoor and outdoor PM monitors and different types of filtration interventions in these homes, and participants also completed questionnaires. Then in 2023, we launched FRESCA-Mujeres, and then during this phase, we enrolled about 50 female agricultural workers from Kern, Kings, and Fresno counties. We installed portable air cleaners in all of the homes and swamp cooler filters on half of the homes. It was designed this way so that we can ensure that all participants had some sort of filtration in case of a wildfire event. And then to characterize exposures and evaluate the intervention, we measured air pollutant levels inside and outside of the homes, collected participants' urine to measure exposure biomarkers, and conducted questionnaires. And now I'll hand it over to Mohammad to provide details on the filtration intervention analysis. Thank you.
Thanks, Ileana. Thanks, Stephanie. My name is Mohammad Heidarinejad. I'm an associate professor at Illinois Tech. I'm excited to be here to present on behalf of the FRESCA team. Looking into the FRESCA, we had 3 different phases. One phase was laboratory testing, pilot intervention, and the full intervention. The laboratory and the pilot was conducted in 2022, and the full intervention was in 2023. Before looking into the lab testing, I want to explain a little bit what the difference between the pilot year and the full intervention. So we used the pilot year to learn more about the lessons learned that we could deploy it for the full intervention. So technically, the number of homes increased significantly from the pilot year to the full intervention. The counties were almost identical. In terms of the intervention, we usually deploy them in June, July, and retrieve the interventions in October. The goal was to make sure if there's a wildfire, we can capture the intervention for the air cleaning during that time. One of the things we learned for the pilot year was, if you look at the intervention types, in the pilot year, we had so many different portable air cleaners. We decided to limit those numbers, making sure all the portable air cleaners are HEPA filters. Also, we want to make sure during the full intervention, all the homes have a means of air cleaning, meaning all the homes, we call it single intervention, at least had a portable air cleaner. And half of the other homes, they had double intervention, meaning in addition to their portable air cleaners, we were also filtering the swamp coolers to make sure the outdoor air coming in is filtered. One of the other things we learned during the pilot year, making sure that we can focus on understanding the usage of the portable air cleaners and the swamp coolers. So all the homes, almost if possible, during the full intervention, they had a plug load logger, so we could see if they're operating the device, if they're operating at low, medium, or high speed. The other thing we learned during the pilot year, making sure having some sort of memory and the monitors for the indoor air quality and outdoor air quality could increase the capture rate. So now we want to look at a little bit before getting to the full intervention, the year looking at the results. We want to learn about what is the focus we did in the laboratory to develop the filtration solution for the swamp coolers. So the team made a visual survey of the homes, and they looked at the homes, their swamp coolers in terms of size, dimension, and their location. 85 of them, we call them horizontal flow. meaning they were going through the walls or the windows and they were not on the roof. So we decided to focus on that because of the safety, also the predominance of the horizontal swamp coolers. As you could see in the bottom, there are 4 figures, and the 3 on the left-hand side show these are usually cubic, but also you have some sort of swamp coolers. They may have a little bit different, basically dimensions, mostly 2 narrow side and then maybe 1 dominant side here. So we looked at different filter types. We'll talk about it more, and then ultimately we focus on these to make sure that we can develop the solution for that. In the laboratory, when the team made a survey, they identified 7 manufacturers for the swamp coolers in the area. We picked 3 of them that they were more common, and we acquired them in the lab. As you can see in the image on the right-hand side, a few different ways of mounting the filters on these swamp coolers were tested. Even in the bottom right-hand side, you could see that we built the enclosure or plenum type on it. We decided to abandon that because it takes a lot of time to do that. The overarching goals for this laboratory testing and the making sure the filtration for the swamp cooler was making sure the media could withstand the wet surfaces, because these swamp coolers have wet surfaces, making sure that it's not restrictive in terms of the flow. So we kind of have a 20% limit in terms of the flow that could be reduced. Also, it should be cost effective, and the owner should be able to acquire the pieces needed to put it together. So meaning limited training or no training is needed for that. Also, we want to make sure this solution is not permanent. It's only during the wildfire season. So as you can see in the results, usually these are good for a few weeks. With that, we did the testing. So if you're looking at the figures here, we have 2 figures. The left-hand side shows 2 types of the coolers. They had centrifugal fans, and then the right-hand side has the axial fan. The vertical axis shows the flow rate. So if you look at the number, usually multiplied by 0.6, you get it in CFM. So if you're looking at it, maximum gets to about 3,000 CFM. The horizontal axis shows the pressure drop in these coolers. So we did testing of blocking different side of the cooler, as you can see the dashed line here. So you get the system.
Should I repeat it from beginning? So one thing we realize here, if you're looking at it, so like the dashed line shows when we did the testing of blocking different side of the cooler, and we get the system curve for that. The goal was to make sure it's only 20% restrictive in terms of the flow rate. So if you're looking at the line here, for the bottom, basically line, that's the cutoff in terms of the pressure drop. And this one is for the upper line. You are looking at a few different combination of filters being deployed here. So we looked at MERV 13, MERV 11, even like some sort of thin sheets being used in terms of the filtration. Also different thickness of the filters are tested. Almost all the filters you see on the left-hand side of this, they meet the criteria here. For the axial fan, that shape, it has like 2 narrow sides. Unfortunately, a lot of the filter solutions didn't work, but we ended up finding some sort of innovative way in the field to deploy filters for those coolers. Now looking in terms of the filtration efficiency, basically removal efficiency of these filters. If we are looking at, let's say we just focus on the left-hand side, looking at this arrow, like meaning if no filter is being used for these swamp coolers, these pads are usually good for more than 5 micrometer, but less than that, when we usually have the wildfire, they are not good. So meaning we need to have some sort of filtration for the swamp coolers. And usually we know these wildfires, it's important to focus on 0.3 to 0.5 micrometer. So as you could see here, about 50, 60% or more than that removal efficiency could be achieved with this filter. Similar patterns could be seen for different cooler types. The left-hand side, these are the laboratory filters. We selected these in coordination and with the manufacturers, also talking to the advisory group. The right-hand side shows the filters that they were locally available and they were tested. There are a little bit more that if we have time, we can come back and explain some of those. So now we have the solution for the filtration for the swamp cooler. So getting to the pilot and full intervention year. So we installed Purple Air to monitor indoor in all the homes in terms of their air quality and 8 nearby outdoor stations. Also, to make sure that we can make determination, we collocate these purple areas for calibration. So we calibrate them with respect to others, and we ended up getting the calibration factors for each of these monitors. One of the things I mentioned in the pilot year, we learned if you solely rely on the Wi-Fi, the capture rate may not be sufficient. So if you're looking at the figure here, these are 46 monitors, and the vertical axis here shows the capture rate. These are different homes and different monitors that we had. We still had a few with the Wi-Fi on the left-hand side, but most of them, they had on-site storage. So as you could see, the capture rate increased significantly when you have the on-site memory. In case the Wi-Fi get disconnected, you still have the on-site storage to collect the data. That was one of the lessons learned that we used for the full intervention. Now let's look at more detail in terms of the field intervention. We call it single intervention, meaning all the homes, they had a portable HEPA air cleaner. So if there's a wildfire, at least they could use these portable air cleaners. And for the other half of the homes, we call it double intervention, meaning both the portable air cleaner and the swamp cooler is also filtered there. So like any outdoor air coming to the space, it's being filtered through these swamp coolers. So we'll see the results of that in the next few slides there. So we call this one double intervention versus single intervention. Before looking at some time series data, let's look at some spot measurements. So one of the goals was to make sure it's not restrictive in terms of the flow rate. So we kind of have the 20% limit there. So looking in July, when the filters were deployed versus October, we call it new versus used. So as you could see over time, when the filters were removed or retrieved, so the flow rate reduction increased more from 13 to 17%. We are still within the 20% range that we have. So indicating that the solutions that they were deployed, they meet the criteria that we had for the design. Now, the next step is, before again looking at time series, let's look at another spot measurements. Important part is the particle removal efficiency, meaning how effective these filters and the solutions are. So looking at new versus used, meaning July versus October when the filters were retrieved. So as you could see for different size result bins, from 0.3 to 1 micrometer. So over time, the particle removal efficiency dropped from 49% to 36%. And as expected for like the filters, as you go up, the filtration efficiency goes up, but also again decreased over time significantly, indicating that the solution is good, but only works for a few weeks possibly. Now we want to look at if really these double intervention solution works. So you'll see a box plot here. We call it constrained PM indoor and outdoor ratio, the vertical axis. So it goes from 0 to 1. And the horizontal axis shows two groups. The first group here is the double intervention, meaning homes with PAC, portable air cleaners, and the EC filter. The right-hand side shows only single intervention, meaning the portable air cleaners being used. So one of the things you are seeing here, the median for the IO ratio is slightly increased when the ECs become on, like these dark blue, from 57 to 62%, meaning slightly the outdoor origin particulate matters are coming to the space, but the filters are still able to filter most of that. But when we are looking at the homes with only PAC filtration, that number increased significantly from 55% to 78%, meaning that those outdoor air coming from the coolers, they are not filtered and the portable air cleaner is not able to catch up with that. So indicating the double intervention is what we are looking at it for here as a promising solution. Looking at the same thing we saw before, like, new versus used, like the first 3 weeks and also the last 3 weeks of the deployment. So you see the same thing here, the IO ratio for the first 3 weeks versus the last 3 weeks. So the first 3 weeks, we are not seeing noticeable changes in terms of the IO when the filters are deployed. But over time, as you could see, that IO ratio increased from 55 to 69%, meaning the filters are not able to catch up over time a little bit more than what you see at the beginning. There are several reasons for that, but It's again indicating the solution is temporary, but could work well during the wildfire season. Now, before getting to the summary, let's look at 2 times. One, we call it non-wildfire period, meaning most of the times that these filters were deployed in that 3-4 months. And as you could see here, again, the same thing on the IO ratio, for double intervention, slight increase, not significant. Similar result happening here for the PAC only, you'll see more outdoor air origin, PM 2.5 are coming in, and the PACs are not able to catch up with that. We can look at during the wildfire season, we had 2 times in August and also in September. You could see the impact is similar pattern, but it's a little bit more severe here. So for single interventions, meaning the homes again with no filtration under swamp coolers, that number increased more than what we saw during the non-wildfire times. One thing to emphasize here, during the study here, we had wildfire, but it was not as severe as previous years. But again, looking at the results here, confirm this solution works well. In summary, we looked at these air filtration solutions for both the pilot and intervention year, and the solution with the filtering the swamp coolers. We call it DIY, do it yourself, meaning the homeowners with no training can do that. We also looked at materials and filters that could be mostly accessible and available to be installed. One thing we had it earlier, didn't get a chance to get into that in more detail. We use MERV 13. It's recommended for the filters. It's also followed the same recommendation that EPA and ASHRAE has. Also, having portable air cleaners with HEPA filters are effective in terms of lowering the PM 2.5 and PM 10 levels in the homes. And ultimately, the solution could be good for a few weeks, but their efficiency and effectiveness will decrease over time. So overall, it's important to make sure these swamp coolers, when they are drawing a significant amount of outdoor air, are filtered during the wildfire season. Before passing it to Stephanie, I want to thank the colleague who worked on this. We have a few of them here in person and a few online, and happy to respond to any questions after the presentation. Stephanie, I'll pass it to you.
Thanks so much, Mohammad. And also big shout out to the larger FRESSCA team and also the team at SOBS for doing a lot of these analyses that I'll be presenting on today for the biomonitoring data. So other than the PM data, we also measured levels of PAHs, VOCs, and metals in indoor and outdoor air. Those results were presented at a previous SGP meeting by Jeff Wagner last November. So today we'll be discussing the PAH, VOC, and metals data in the urine samples. The FRESSCA-Mujeres study also did measure biomarkers of stress in urine and included saliva telomere length and silicone wristbands to measure pesticides for a small subset of participants, but we will not be covering those data today. So here's a look at our demographics. We had 51 participants who provided at least one urine sample. They were all non-smoking, Hispanic, Latino women, who primarily spoke Spanish. The mean age was 41, and a majority owned their home and had Medi-Cal or Medicare, and most participants were either farm workers or worked in some sort of food packaging and processing facility. So we put together this timeline to try to help clarify what data were collected and when, since there's so many moving parts. And as we stated, the study was designed to try to capture exposures during a wildfire event. So we collected a first morning void sample in the spring/summer months to establish sort of baseline exposures. Surveys were also conducted at that time. At the same time, we installed purple air monitors to monitor for PM and passive air samplers for PM and metals at the homes of the participants. And then we installed the portable air cleaners in all the homes and the swamp cooler filters in half the homes in hopes to prepare for a wildfire event. As we did not have any major event, we waited until October to collect the urine samples. We collected one in the evening and then another a first morning void. This design was chosen to see if there might be any potential differences in the metabolites of pHs and VOCs after spending time in filtered air. And that's because the pHs and VOC half-lives are short, generally within 6 to 8 hours. And then active air sampling was conducted for the 24-hour period preceding the collection of the fall morning samples. And we collected VOCs, pHs, and metals data for that. So getting into the data analysis, non-detects were imputed with reporting limit over the square root of 2, and we did not conduct any analyses if we had detection frequencies less than 65%. The urine results were adjusted for specific gravity to account for dilution and were log transformed. However, we did use creatinine adjusted values for our comparisons with NHANES. The number of samples may change depending on the analysis, as not all participants provided all 3 urine samples. And then for any of our geospatial analyses that we're including today, we were provided with approximate participant locations to not include any PID. So here are the detection frequencies we had in the chemicals measured in urine. And you can see we had pretty high detection frequencies for almost all the chemicals. The 1,3-butadiene, benzene, and manganese all had low detection frequencies, and therefore they will not be included in the analyses on the following slides. So one of the questions we had was we wanted to see if the levels of pH and VOC metabolites decreased after spending time in filtered air. We did not look at metals for this question as their half-lives are much longer and we would not expect to see a difference in such a short amount of time. We also checked if we could see any difference in metabolite levels based on intervention type, similar to the question that Mohammad wanted to answer using the PM data. So participants, as I mentioned, provided urine samples in the evening, generally when they got home from work, and then again, about 12 hours later after sleeping at home in the morning sample. And so what this plot shows is the estimated % change in concentration between a participant's fall evening and fall morning urine sample. The color blue here, it's maybe a little hard to see, means the difference was significant. And so you can see that metabolites of fluorine, phenanthrene, and pyrene were either about the same or lower during this time period, while metabolites of naphthalene increased, particularly 2-nap, and this might point to perhaps an indoor exposure source of naphthalene that we'll get into a little bit later. And then looking at the VOC changes, again, this plot shows the estimated % change in VOC metabolite concentrations overnight. And similar to the PAHs, you can see that metabolites of VOCs were about the same or lower during this time period. And with acrolein being significant and about 20% lower in the morning samples than the evening samples. So as I stated, metabolites of both pHs and VOCs generally decreased after spending time indoors, except for naphthalene. This might partially be explained by air filtration, but it could also be due to differences in behaviors during work versus while they were at home. We did look at differences in the spring versus fall samples based on paired t-tests of the morning samples, since, as you mentioned, we were originally expecting much higher pollutant levels in the fall due to a wildfire event. However, as there was no major wildfire event, we did not see any significant differences between the fall and spring morning samples. We also did not see a significant difference in metabolite levels based on the intervention type. And Jeff Wagner's team had a similar finding for the pHs and VOCs in air. Again, since we didn't have a major wildfire event, I think it'd be hard to see differences at that level of granularity in the biomarkers especially. And also our ends reduced even further when we had to split them among the 2 intervention groups. And additionally, it was found that a majority of participants were not actually running their swamp coolers the night that we collected the urine samples and had the 24-hour air sampling, which makes even more sense why we weren't able to see difference. Okay. So the next question we had was, how do the levels of metals and pH and VOC metabolites in FRESSCA-Mujeres compare to NHANES? Starting with metals. So we use the geometric means of each participant's geometric mean across all 3 time periods to compare to NHANES. We saw similar results when we compared NHANES to each time period separately, which is why we felt comfortable with this approach. You can see here that the geometric means of antimony, arsenic, and cadmium were similar or lower in FRESCA compared to NHANES non-smoking women. Mercury was higher, though not significant. Nickel was the only metal where we saw significantly higher levels than NHANES. However, we also had 7 cases of mercury and/or arsenic levels above Biomonitoring California's levels of concern, which I'll be going into more details a bit later. So for nickel, it was about 1.5 times higher in FRESCA compared to NHANES. We didn't find anything, unfortunately, that jumped out based on the questionnaire data. And we asked questions such as working with metals, either through their occupation or hobbies, and we didn't see any difference based on occupation. We also did not have any detects in the FRESCA air sampling data that was for the 24 hours before sample collection. However, we did have a number of detects in the passive air samplers and also the EC filters, and those were up for a much longer period of time. So the fact that we're seeing nickel in those samples might be more relevant due to the long half-life of nickel. This also indicates exposures might still be coming from air since they were captured in those filters and the samplers, and nearby oil and gas activities might be a potential exposure source, which again, we'll talk about a little bit later. And just to check, we did look at the drinking water data and did not find any detects of nickel in the drinking water data for these participants. So as I discussed, we had 5 participants who had mercury above Biomonitoring California's level of concern, and they all received early notification. 3 of those participants agreed to participate in an additional exposure survey. The image to the right here includes a number of products imported from other countries that CDPH has found to contain mercury. These are skin creams. 2 of them were used by our participants. And we connected these participants with a team at CDPH who was actually able to test the skin creams of the participants and found mercury in all the samples of their skin creams. And CDPH also conducted home assessments for 2 of those participants and did not find any other exposure sources in the home, which confirmed that the skin creams are the most likely source of these high mercury levels in the participants. And then we had 3 participants who had total arsenic above Biomonitoring California's levels of concern, and again received early notification from our team. 1 participant had high levels of organic arsenic, which is likely due to seafood consumption and then less of a concern. 2 participants did, though, have elevated inorganic arsenic levels. 1 agreed to participate in an additional exposure survey. Unfortunately, nothing really stood out based on the results of that survey, but we think we can at least rule out drinking water for this participant, as they were using vented water for drinking and cooking, which removes arsenic. And we also did not find any high levels of arsenic in the drinking water data for this participant. Okay, so next we wanted to look at VOCs and any potential differences in the metabolites in FRESCA compared to NHANES. So metabolites of acrylonitrile and crotonaldehyde were similar or lower than NHANES, but acrolein and propylene oxide were significantly higher in our FRESCA population than NHANES non-smoking women. And so we wanted to look into what exposure sources might be contributing to the high levels of acrolein and propylene oxide metabolites in our participants. And while all samples, so spring and both fall and morning samples, fall, morning, evening samples were generally higher than NHANES, we still did see higher levels in the post-work evening samples for both acrolein and propylene oxide. So it's 27% higher in the acrolein metabolites and 16% higher in the propylene oxide metabolites. We also found for acrolein that the levels were 17% higher for each additional hour worked outside. And we think that this points to a potentially exposure sources that are happening outside the home for these participants. And we did also find evidence that acrolein and propylene oxide were ingredients and pesticides that were applied in the region in 2023, and that was based on DPR data. And unfortunately, we did not have FRESSCA-Mujeres indoor or outdoor air monitoring data for acrolein propylene oxide. Okay, and as I alluded to, additionally, for both acrolein and also nickel, we wanted to see if the high levels in our population might be explained by oil and gas activities in the Central Valley. Elevated levels of acrolein were found in air in Lost Hills, a community within Kern County, which is one of our counties, and that's based on data from CARB SNAPS report. Nickel is also often detected in air around oil and gas activities, such as oil refineries. And you can see in this map that there are literally hundreds of oil and gas wells in these communities and a number of oil refineries as well. We only had 6 participants, however, who lived within 3,200 feet of an active well. And we chose that buffer because it is considered the health protection zone around oil and gas operations, and that's out of Senate Bill 1137. Though we are planning on looking at some larger buffer zones in the future as well. And even though only 6 participants lived within 3,200 feet of a well, we don't have the locations of participant work locations, which may be more relevant to their exposure periods, since that would be where they would be exposed to unfiltered outdoor air. And yes, we do not have those locations, unfortunately. Okay, switching to pH metabolites in urine. So again, we compared the geometric means of participants in FRESSCA to NHANES and found that the pH metabolites were all lower in FRESSCA-Mujeres women, which is good news, except for 2-naphthol. So you might recall hearing a lot about 2-naphthol from our SAPEP and biosphere studies, where it was also elevated. So you can see in this graph here, we compared the levels from FRESSCA-Mujeres, which were all non-smoking Hispanic women, to a subset of women from our Biosphere study, which were also Hispanic women. And then we wanted to look specifically at the Hispanic women in NHANES, since from some of our previous analyses, we know that it is generally higher than the average levels in NHANES adults, either women or adults. Both male and female. And you can see here that the FRESSCA Hispanic women had similar levels of 2-NAP compared to Hispanic women in Biosphere. And then the levels of 2-NAP in both FRESSCA and Biosphere Hispanic women were still 2.5 times higher than Hispanic women in NHANES and 4 times higher than women in NHANES. Just want to note here, you can see that the most recent data we're still working with from NHANES is from 2015 to 2016, which is almost a decade ago. And we also saw something similar in our Biosphere study, these correlations, and you can see that the pHs were all significantly correlated with each other, including 1-NAP, except for 2-naphthol. The difference is pretty stark here, so we think there's definitely a unique exposure to 2-NAP that is not relevant to the other pHs. So we showed earlier on in our slides that the 2-NAP levels were 16% higher in the morning samples versus the evening samples, again, pointing potentially to an indoor exposure source. We did not find any significant associations with cleaning product or air freshener use, which is different from what we had found in Biosphere, unfortunately. Though similarly to Biosphere, we did not find any significant associations with diet, such as consumption or cooking of fried or smoked foods, though we might be missing some other associations with dietary sources that we did not capture in our questionnaire. Additionally, some recent data that we've come across and from speaking with other biomonitoring programs indicates that 2-NAP is generally increasing, both in the country and actually globally, but nowhere near the levels that we are seeing in SAPEP, Biosphere, and FRESSCA. So again, still trying to piece together the puzzle that is 2-NAP in our populations. But with that, I will turn it back over to Ileana, who will discuss the community impacts and perspectives of the FRESSCA-Mujeres study.
Thank you, Stephanie. Can we go to the next slide, please? Thank you. So the community response to FRESCA has been overwhelmingly positive and incredibly insightful. Participants expressed deep gratitude for the portable air cleaners, for the free maintenance to their swamp coolers that we provided, and they reported noticeable improvements in their indoor air quality and even their health. Although we didn't experience a major wildfire event during the study period, many participants told us that the interventions made a real difference during dust storms, which we get a lot. With the swamp cooler filters in place, participants felt far less dust penetrated their homes, making these events a little bit more manageable. However, participants did note that the biggest challenge was the bulky filters and the difficulty to install them and remove them. Beyond the air quality, though, participants were genuinely shocked to learn about the mercury-containing skin creams. A few actually owned these products, as you heard, and were super grateful to understand the health risks that they were posing. Most importantly, participants felt empowered by being part of this research. It was a bit hard to grasp the technical analysis in the results packets that they received at the end of the study. But most participants already knew that they were being affected some way or another. They just didn't understand at what levels. And this study brought them that sense of credibility to their stories that they've been telling for years, but no one has really taken seriously. And at the end, they really just wanted to know that their participation would lead to better and more accessible filtration options for agricultural communities in the valley. Next slide. And as mentioned at the beginning, I'm going to play the rest of Erika's video where she talks more about how the FRESCA study impacted her.
Desde hace un tiempo me proporcionaron ayuda con un filtro de aire. A veces cuando yo cocino sopes, veo la diferencia en el filtro de aire, que la raya se pone roja. El mismo filtro nos está indicando que es veneno para nuestro cuerpo, oler ese humo negro. Ese humo es el que hace que a uno se le vayan dañando los pulmones, los riñones y todo. Ahora veo la diferencia que ha tenido usar un filtro de aire en mi casa. Yo también usaba antes un inhalador de asma y últimamente, sin darme cuenta, lo dejé de usar. Desde hace casi un año lo tengo guardado. Antes, si no lo usaba, no podía ni respirar. Y ahora, como dicen, hablo hasta por los codos.
Next slide, please. Lastly, I'm just going to talk about the next steps for the FRESCA-Mujeres project. We are planning to promote ways to reduce exposures in the FRESCA-Mujeres communities and beyond through portable air cleaners in homes, swamp cooler filters during a wildfire event, and conducting some community engagement to reduce those exposures to mercury skin creams that we found and to arsenic. We also want to continue research to identify potential exposure sources of naphthalene and other chemicals of interest. Through this, we want to combine data from the FRESCA-Mujeres biosphere and the ZAPIP to identify trends and also assess geospatial predictors of traffic exposures. And with that, that is the end of my portion of the presentation. I'll pass it back to Stephanie. Thank y'all.
Thank you so much, Ileana. And here we have our very large study team for the FRESCA study, with whom we could not have done any of this work. So thanks, and some of them are here today, so it's nice to see them. And of course, thank you to our community members who participated in this project, the scientific advisors, and the community advisory group. And here's some funding statement. And with that, we'll take any questions for any three of us.
Thank you, team, for a great presentation. Any starting off with clarifying questions from the panel? Go ahead, Tom.
Tom McCone. I'm really also kind of fascinated by the two natural and why that's different. And so you looked at diet, but I was wondering if you looked at how food is prepared differently in California, like, or even such a thing as our natural gas. I assume they're using gas. So it has a different composition than the average we would see in NHANE. And again, thoughts I had about what might account for different indoor level of methane.
That is an interesting thought, because I'm pretty sure all of the FRESSCA participants use gas appliances and had a gas stove. So I don't, yeah, we've never really looked into if there could be different compositions of the gas in California or particularly in Central Valley. So that's some associations we can run. I think we're mostly looking at VOCs for those associations, but yeah, we should look into naphthalene specifically. Thank you. Sure.
It's a simple question, but did you have a measure of toxicity in selecting the substances you studied, or did you just take what was present?
Sorry, do you mean how do we choose the metabolites to measure?
Yes.
Well, we had chosen pHs, VOCs, and metals because, as we had mentioned, the goal of the study was to capture a wildfire event, and we are aware that these are generally apparent in wildfire smoke. And the exact metabolites we were able to run, it was a bit limited by what our labs were able to run. And of course, it had to be on the designated list, but there was evidence that all the ones that we chose are often present in wildfire smoke.
Tamer Durrani. I thought you mentioned that you guys had also measured biomarkers of stress in urine. Can you talk a little bit about that?
Yes, so for our other studies, we measured only 3 or 4 biomarkers of stress through Nina Holland's lab. And for the FRESSCA study, this is not really Biomonitoring California's part of the study, but as the FRESSCA-Mujeres study, they measured 19 different biomarkers of stress from a lab out of New York. And so we do have plans to look a little bit more closely at that data and see if we can see any associations between the biomarkers of exposure and effect. But we're not as clear how to handle all those 19, so it might take us a little bit longer to try and make sense of all the data.
Go ahead, Jenny.
I'm sorry if you touched on this, but could agricultural burning contribute to the naphthalene exposures or metabolites? I wasn't sure if that was an area that had a large contribution, but I know much of the Central Valley does have a fairly large contribution. Thank you.
I think it could, although we aren't seeing very high levels in air for naphthalene. You know, it's always the most abundantly detected PAH, but at levels that we see in other areas too, where we don't see the same high levels of 2-nap in the urine.
Thank you.
How about the prevalence of use of mothballs in this population?
Unfortunately, we did not ask about mothballs. This is going on at the same time as our biosphere study, so before we really learned that we should add that to a future study, which we are going to do for the chair study, we did not ask specifically about mothball use, but for every single person to be using mothballs, it just seems unlikely, although it might still be possible.
I mean, not every single. I mean, was it substantially higher in every single person, or are we just
I think
the average here?
I think every single person had very high levels. Of course, there was a range. I don't know, Dan, if you have a little bit more details on that, but
That would be unusual, I would thought.
Yeah, sorry, yeah, it was generally higher in the study.
Oh, that's right. When we talked to the Minnesota biomonitoring team about some higher levels that they were seeing, though not as high as ours, they had asked a question about mothballs, and I think they only found like a few people had been using them in their population.
Right. I mean, I wonder if there are differences in their population versus here.
It's true, there were, yeah, they didn't have as many Hispanic people in their population. And interestingly enough, they had found elevated levels in Black participants, which if you recall, in Biosphere, we had found a similar finding, although we only had a few Black participants in the study, so we couldn't really make any conclusions. But it's interesting that they're finding a similar trend. And then there is a study that recently came out in the East Coast, I think Maryland, DC area. It was a small study looking at occupational exposures to hairdressers, both Black and Latino women. And that's the only study we found that has come close to the levels that we're seeing in our population, which is very interesting. But our population was not obviously hairdressers. So yeah, that's something else that we're puzzling over.
Tamer Durrani, can you talk about the exposure survey that went on for, I know you did for mercury, but for arsenic, how did that go about, or is that, can someone review it? How did that occur once you see this level above a threshold?
So I might pass it to McKenna, but so when we are notified that the levels are above our level of concern, we essentially send them a packet that lets them know that the levels are above the concern and potential exposure sources. And then we invite them to participate in another exposure survey that asks more detailed questions about potential exposure sources. So for arsenic, we even asked about like teas, supplements, where they got their drinking water sourced from, things like that. And for that one participant who conducted the additional survey, we were not able to find anything significant that stood out. We asked even about like specific brands that we looked into and couldn't find anything. I think you covered it.
We can also open up to a general discussion if we haven't already.
I have more questions, and part of it is same thing, trying to understand what you make of it. So looking at that same table here, comparing the VOCs, and this is Jose Suarez, by the way, sorry. Naphthalene, right, is higher, but then the other part is substantially lower for pretty much everything else. What are your thoughts on that?
You mean for the pHs in general, why they're lower?
Well, the ones that are at least shown here, right?
Yeah. That is a very interesting question. I'm not really sure why they're so much lower. They're significantly lower in our population, which, we take as good news, but I can't really say why.
Yeah, I mean, it's something that once you're getting to that part of it,
Yeah.
writing and doing the discussion, it is also very interesting finding what is it about these populations that are leading to that. But it sounds like somebody maybe has a thought.
Yeah.
I was just going to point out, I believe this is McKenna Thompson from OEHHA. I believe our collaborators at UC Berkeley have found that pHs in air in the Central Valley in general have been going down over the past 10 years. So that could be a contributing factor.
And is that due to like different regulations? Remember? Yeah. Okay, great. That was John Baum's in the affirmative.
Less diesel emissions and less agricultural burning.
Okay, John Baum said less diesel emissions and less agricultural burning. Okay.
Would it be enough to explain this lower concentrations versus enhanced for that matter? Is the pollution substantially lower as a result of that in the valley than the average US area?
No, actually, this is John Baum again. Actually, the levels are higher and they've gone down substantially, but they're higher than many parts of the country. I mean, the Fresno area And actually at the Bakersfield area, those are two of the most polluted cities in the country
Yeah, that was
from
my-
traffic-related air pollution.
That was my understanding too, but that's coming back to this, right?
Great point. Great question that we'll look into further.
Oh,
Oh,
I can, I have more questions, but I'll.
After him.
after him.
Oh, no, please go ahead.
Okay, well, it's kind of related to that, just that, oh, Susan Hurley from CDPH Biomonitoring. Just following up on John's point, while the levels of a lot of pHs in the air may be going, or may be higher in California, the other thing to remember is we do have this temporal issue where we're comparing our levels to data in NHANES that was collected 10 years ago. So we can't tell if this is a geographic issue or a temporal issue.
That's a very good.
Yeah. Great point. And even that for fluorine, it was 2011 to 2012, so even longer ago. And I don't know how hopeful we are that any new data might be coming out soon. Jose?
Close to buddies. So another big thing was compliance. That you were concerned about. Tell me a little bit more about. Do you have any numbers about compliance in that sense? And part of the concern seems to be the overnight use too of running the swamp cooler or not using it for that matter.
Yeah, I mean, usually in general, like during the nighttime, it's cooler. So they are not running the coolers as much as that needed for the study here. So maybe like change of the study design, is it like better to do it maybe during the day or something rather than like morning and nighttime?
Well, I guess the problem is if they were at work during the day though, then it wouldn't be capturing those exposures anyways. Or can you talk a little bit more though, Mohammad, about like the plug load
Sure.
and sort of how you're able to determine?
Yeah, like if we, like for all the devices, like portable air cleaners and swamp coolers as much as possible. So we had plug load loggers. So meaning that we know when they're running it and how are they running it? Are they running it at low speed, medium speed, or high speed? So we're able to capture like their usage and understand, especially for portable air cleaners and the swamp coolers, if you're running it at a low speed for portable air cleaners, so you're not getting enough clean air delivery rate, PADR. So ideally, you want to make sure you run it at high speed to get that portable air cleaner like removal efficiency needed. The same thing with like the swamp coolers. If you're running it at a higher speed, meaning you're pulling more air coming in, even though if you have the filters on, they might not be effective at some point. But I would say in terms of like compliance and running it during the nighttime, we were able to identify a method to know when they're running their swamp cooler based off the outdoor temperature. We call it like predicted to be on and also like measured on. And during the nighttime, usually it's cooler, so they are not running those coolers as much as you could see in terms of the filtration efficiency there.
Martha Sandy, OEHHA. So I wasn't part of the study design team, but a couple years previous to when they were in the field, we had multiple summers with lots of wildfire smoke events when it was hot, the dog days of August, for instance, and you would predict they would have had their swamp coolers on at night. And someone may want to add more.
Yeah, that's true in terms of the wildfire. I think the maximum we got in that September was about maximum maybe 35 microgram per cube meter. Compared to what you see during the wildfire time, usually that gets to 100, 150. So we didn't have that magnitude at that time. The other one is like, of course, the extreme heat become a factor there. When it's like significantly warmer, you run the cooler more than before.
This is Marissa. I had a question. Did you get any feedback from participants about the use of the swamp coolers in terms of noise or the expense of running it as an intervention? Is it something that would be acceptable to the families to have them on?
Sure. I mean, we had a survey. I think, Julie, you looked at the survey, but I can answer a few things. Like looking at the pilot year, for example, we had DIY air cleaners, like these Corsi Rosenthal, air cleaners there. Like usually they didn't like it because it was moving a lot of air in the room. So they were like putting it in the closet or somewhere else. So that's why we decided in the food intervention to go with smaller units, that they are more effective, but smaller, and they don't run that amount of airflow in the space. In terms of the swamp coolers, I think one of the complaints they had was, if you're getting these swamp coolers with different, like very random shapes, like the narrow one, so you end up maybe using like 4 or 6 maybe filters rather than 3 or 4 that it's like recommended. So that's why it becomes a little bit bulky, and they didn't like that one. But I think it's an iterative process. Over time, you like run different filters, install them, get the feedback, and over time you can polish these DIY solution with a combination of filters and even like thin like sheet filters that could be appended to those like narrow version of the swamp coolers. Julie, I don't know if you want to add anything about the survey. We did a survey of the 50 homes, correct?
Yeah.
And Ileana too, might have.
Hi,
Ileana
Julie
as
Von
well.
Baron, UCSF. We did ask some satisfaction related surveys for the ECUs, and one of the things that I just wanted to add to what you already said was that cost was a definite issue. We asked about a price point, would they be comfortable spending, because it is a DIY, and I think it was pretty low, like $20 or less is what they indicated.
That's true. Yeah, I think if I recall correctly, it was 20. Thank you, Julie. And our solution from the beginning, we were aiming about maybe $100, but we ended up going a little bit higher than that. Also, like Ileana, if you have more from the field, that would be good.
Yeah, I don't think we ever received any complaints about noise or the air cleaners being too loud, nor the air filters on the swamp coolers. I think what Mohammad said about it being bulky and just the size of it was the only issue. But yeah, no complaints about noise.
Go ahead, Paul. Oh, sorry, you need a mic.
Thank you, Carl Kreiner, UC Riverside. I want to ask a big question. You've studied a group of substances that are worth studying. If you took the universe of airborne toxicants, what have you left out? Do you know? Have you thought about them?
I mean, we do think about them ahead of all of our studies of sort of what's most relevant to measure. We always do research ahead of time to figure out what we might expect to see based on the exposure sources that we're interested in, particularly air pollution. And again, though, it also depends on what we're able to measure based on our designated list and also what our labs can measure. So I think that is a big limitation, is sort of what methods have been developed or not been developed. But I'm sure there are things that we are missing, and we continue to evolve and add more chemicals as we can. But if you have any ideas.
Let me ask you about one.
Okay.
Air particulates are really nasty. I mean, you haven't done those, I suppose, or these are components of air particulates, but should the air particulates be studied in a similar way?
Are you talking about particulate matter in particular, like a biomarker for particulate matter? I'm pretty sure, I don't know if Jeff Wagner's on. I think he's done some work sort of looking more closely at like breaking down the particulate matter in air and getting more ideas of like what it is actually made up of. Jeff, are you on and want to talk a little bit more about that?
Yeah. So I'll go on camera. Yeah, our lab did, in addition to the continuous monitoring that Mohammad was talking about today, we did electron microscopy of the particulate matter. And so we were able to get the different size fractions, the different chemical components, and some source information about the different particles types. So we looked at fine particles, coarse particles, metals in the particles. But I have a feeling you might also be asking about what Stephanie mentioned, which is some kind of biomarker of the particles themselves, and that's an interesting question. I'm only familiar with that type of work for microplastics personally, as far as particles that don't dissolve and persist in particulate form in various fluids and tissues. So I don't know. That's an interesting question. Also asbestos, other types of persistent particles that don't break down and would be detectable in tissues or fluids. I think that's a interesting question.
Hi, this is Rebecca Belosa from OEHHA. We do have 3 comments from attendees online. So I'll start reading the first one. It's from an anonymous attendee. I remember hearing about widespread outdoor grilling in the Central Valley and that it contributes to poor air quality. Would this contribute to naphthalene? Though it seems odd that other pHs didn't increase given grilled food contains high levels.
Well, yeah, I think they stated it. They answered my question. But also, again, we did find naphthalene in the air, although not at particularly higher levels than we've seen in other studies. And we did not see any associations with naphthalene in air and the naphthalene metabolites. But we only had 8 outdoor air monitors, so we didn't have as specific of data for the outdoor air as we did for the indoor for the chemicals, including naphthalene.
Thank you. The second question is also from an anonymous attendee. I believe nap containing mothballs are not allowed to be sold in California.
Great point. That is also true, although you still could technically buy them. I think we've even found them in some stores, and you can buy them online, but you are not supposed to.
And the third question is also from an anonymous attendee. How does your LOD compare to NHANES for naphthalene? And I believe Dan Sultana may have an answer to that.
Yeah. So our it was about half of what the NHANES LOD was, but both NHANES and FRESSCA have 100% detection rates. So we don't think it's a LOD differences isn't explaining the higher levels we're seeing.
Such a great job. Thank you so much.
Any other questions online? Thank you, Jose.
Since we're talking about naphthalene, I'm looking at here the results that you have for the overnight difference.
Mm-hmm.
So this is so these differences are actually not the night and the morning, kind of. Tell me a little bit about that, because it is, you collected the urine in the morning and then in the evening, right?
So the first sample was collected, let's say on a Tuesday after work. We instructed them immediately upon coming home from work, take a urine sample. And then 12 hours later, when they woke up, to take the first morning sample. Yeah, so
Okay, so it was evening and then morning. Okay, so then it makes sense. So I mean, the interesting thing here is that the concentrations do go up overnight.
I know.
Which really is pointing not at a nutritional source necessarily. It takes a little bit of time for it to, if they ate something at 5 p.m., some meat that had it, maybe it gets absorbed and you see it in the morning. The other one would be maybe there's something in the indoor environment that's leading to that.
And, you know, based on this recent study that came out on hairdressers and just some more evidence that we have that, you know, it could be used in dyes and fragrances, I'm wondering if it's, you know, in some sort of personal care products, and it's maybe being hidden under the label of fragrance. We don't know, but that's one of our pet theories.
Under fragrance, you would think of naphthalene, really?
Yeah.
These measurements are conducted in October, right?
Correct, yeah.
So that's
This
also-
one specifically October, yeah.
So that's why maybe during the night time they don't need to run swamp coolers as much.
Exactly, yeah.
And that was the time that the swamp coolers were put on, even though there was no wildfire too. So there's kind of a less of a kind of maybe.
Yeah. We had a hurricane during that season where we actually, I can't remember if you were there, Mohammad was there, but a team had to go and remove, at least CCJN was very involved, remove the filters during the hurricane and then put them back on. So it was a very strange year that we couldn't have really
No, I do want to congratulate you though for the whole, I mean, you can tell there was so much thought process going in there. It is very challenging to do an intervention like this, especially with the cost, the filtration, the monitoring, the biomonitoring, so many different components. So in that sense, I think it was a very successful intervention. And not only from the indoor part of things, of course, it didn't turn out with all the VOCs and things like those, but there are reasons to believe that given the right conditions, it may actually be far more beneficial than what we're observing, right? There were no major events of fire that happened for you to really look at the differences. So I think it's very encouraging that this is, very easily implementable, and it seems to be moderately well received intervention by the different communities.
Yeah, thank you. And want to make sure I give a big shout out to Gina Solomon and Naomi Martinez, who were the initial PIs of the FRESCA and FRESCA-Mujeres studies and sort of brought this larger great team together.
I just have one follow-up question to this conversation. I was wondering if I guess some of this makes me want to look into the work of Ami Zoda, who's done a lot on hair products and chemicals. And I was wondering if that's come up.
Yes, we are looking into it. We are aware of it. Yeah.
Great. And then I was just also wondering about the energy costs, whether that was of concern.
Not a concern, because in general, swamp coolers, like the cost of operation, it's about like maybe 1/4 of if you're running like split systems.
Okay.
So like that's not a concern, but technically if you're adding a filter to the swamp coolers, you're increasing a little bit the power consumption, but not as much as like that could be a concern.
Great.
Jenny has a question.
Okay. All right. Jenny, want to go ahead?
Sure. If there's time for just a quick question. I was just wondering about housing type and if it was differed from other housing. And I guess I was just thinking of that whole FEMA trailers and formaldehyde, thing with the Hurricane Katrina. So it just made me think about housing type and if they're more likely to be manufactured housing or something like that. Thank you.
Yep, they're usually like manufactured housing, smaller ones in terms of their like square footage, but they are usually smaller than the typical we see in the US.
And I think for the barn monitoring samples, we did look into any potential differences based on housing type, and we did not see any.
Thank you.
And just going back to the energy cost question, like for different projects, we are paying participants for running the portable air cleaner all the time, but that doesn't help to make sure they're running it.
All right, if that's it for questions, I think we'll wrap up, and thank you to the FRESCA team for a great presentation. So in our next agenda item, we will be hearing from Stephanie again. Sorry, you can't sit down yet. She'll provide a brief overview of the planning for SGP meetings in 2026.
Thank you. Almost forgot about this one. So as Amy mentioned, I'm just going to briefly discuss our plans for next year's SGP meetings. So we've worked with the panel, always very difficult since everyone is so busy, to select the following dates for our meetings in 2026. So we have a meeting on Wednesday, March 4th from 1 to 4 p.m. And then on Monday, August 3rd from 10 a.m. to 4 p.m. and Monday, November 16th from 1 p.m. to 4 p.m. We're still going to be making determinations on each meeting's location. So we'll let everyone know closer to the meeting date and we'll update on our website. But we will still be having the hybrid format throughout 2026. So we will also still have our standing agenda, which includes a general program update and then more detailed project updates, such as updates on our surveillance studies and community studies. As always, we'll also have time for discussion and input from the panel and audience. These are some other potential topics of interest that we've put forward that we could consider exploring. And these include either internal or guest speaker presentations on the use of artificial intelligence in class-based semi-targeted screening. Seems we can't escape AI, even if we try. Exposures to microplastics, updates from international biomonitoring programs. I think would be really interesting to hear what they're researching and some of their results. And then, of course, impacts of climate change, which has been on our list for a while, such as wildfires, droughts, et cetera, and their impacts on chemical exposures. So now we welcome any input from the panel and audience on these suggestions and additional topics that we might consider. So I'll stop there and see if anyone would like to add anything or has any questions. Okay, it sounds like we have something online.
Yes, we have Fung available. Let me unmute you.
Fung, are you speaking?
I'm asking her to unmute. Well, maybe we'll come back.
Okay, maybe we'll take Tom's question first.
Okay, not a question, I guess, comment. So the use of artificial intelligence is probably a good idea. I mean, I think that's really emerging and to see how it fits. I was looking at the climate change issue, and I mean, I know you're already doing studies about how climate change affects exposures to PM and a whole range of pollutants. So I'm just wondering if there's a way to begin to integrate, I mean, not to call it a biomarker of climate change stress, but if there's a way to begin to organize, the multiple stressors that arise from a changing climate into some way of expressing through stress biomarkers or exposure biomarkers how things are changing in the population. So, kind of quote, say, a climate change biomarker, but it might be possible to do something like that, to define, an array of things you could see in blood. It would show the rising change in those markers of stress and exposure that we could associate with climate change. Kind of a wild thought, but I mean, it would be different than just individual studies that say wildfires or heat stress or one thing at a time, but more of an aggregated approach.
Yeah, that's a great idea, and it would be interesting to look at the biomarkers of stress. And the FRESSCA study did collect telomere length in saliva, which I think is also really interesting. And I don't know if that would be potentially something to look at too. Maybe not I don't know if our program could do that, but for others.
I have a comment here for Oliver, actually. Questions, more so. Are you using AI when you're running untargeted analyses and things like those?
Yeah, so in principle, AI is a multivariate analysis, if you like. So if you have many parameters and you have some output, you can always use AI. So it's a little bit like a progression from machine learning that we had in the past, right? So it's not in the sense AI was already invented in the 1960s, but they didn't have the computers for it, right? Now we can get really complicated, complex, questions answered this way, as you all know. Now, for a non-targeted analysis, my own lab, we do it for retention time prediction, right? So when you have, let's assume you have 1,000 or 2,000 compounds that you see, and you want to identify them. The question is, how often are you wrong, right? And how can you be not so wrong when you say, I found to NATO or whatever, right? Instead of like somewhere else, some other isomer. And that's where we use it. But we also use it for multi-omic integration. So when you have, for example, the prediction of microbiomes, and you want to see what can they together produce. So any of these AI methods is really looking at large data sets and complex data sets. So the question is that I would have here is, do we have those data sets? And do we have some kind of outcomes that we could, basically regress on? And it's like a regression, just like a little more complicated than a regression, but yeah, right? So that is how we use it these days. Can there be other uses? Yeah. I when I looked at this topic, I thought, like, do we have enough experts or literature to kind of fill it, right? That was a little bit my question.
Sounds like you might be one of them.
Oh. Yeah. But okay. But in terms of environmental exposure, right? That's the thing. And what exactly would we use it for, right? When you look at all the presentations we have had here, they're usually univariate. You have a compound, you have a regression in time, or and then you have box plots, before after, right? So this is like classic statistics, right? Which is fine, and also to Tom's question, right? Can we get a multi-stress composite? That's an AI question, actually, right? So, but then the next question is, do we have the data for it, right? And also some kind of, where do we get the data? Is it like coherent? It's not that easy. It's easy to say AI, it's hard to get the data for it. That's what I'm thinking.
Great question, great answer, Oliver. Thank you. Did Fung ever figure out how to unmute? Okay. Okay. Well, we welcome input anytime to our email, or you can contact me directly. Oh, Oliver does have something.
So, I had wondered a little bit what our target lists to our, chemical lists. Should we also want an update on that? And, when we put things on a designated list, have we considered measuring some of them, or other new chemicals that we should discuss? I have the feeling we haven't done it for a while.
Yeah, the last time was expanding the PFAS list a couple of years ago, but yeah, and certainly if there's any chemicals that people have in mind that they have interest of adding to the list, if it's not already on, please let us know.
Yeah, maybe just before I wrap up, I'll just have maybe one other comment in that, I personally am really interested in the combination between that first, the AI or use of semi or even non-targeted screening, potentially in ones that have already been either biospecimens that are available or analyses that have already been run, and then rerun them with wildfires or even other climate change factors in mind. So kind of go back and reanalyze the data with kind of new exposure metrics, maybe separating them out by maybe a high climate stress versus not, and then see if there are any differences in some of these non-targeted things based on that. And
yeah, thanks. Yeah, that would be very interesting to see.
At least if it's already done, then it's maybe not so costly to. Great, I think then that puts us into the open public comment period. Thank you, Stephanie, for the program plans for next year. So we have about 10 minutes allotted for this period. So webinar attendees can submit written comments and questions via the Q&A function of Zoom webinar or by email to biomonitoring@oeha.ca.gov, and we will read them out loud. And if you wish to speak, please alert us with using the raise hand feature in Zoom, and Rebecca will call on you to share your comment live. And then if you're attending in person or wish to comment, please come to the front or raise your hand and we'll call on you and bring you a microphone. And for the benefit of the transcriber, we encourage you to identify yourself before providing comment, and however, there's no obligation if you would like to comment anonymously. Usually the quiet before the storm. And are there any online?
No, we haven't received any comments online.
There will be a transcript of this meeting posted on the Biomonitoring California website when available. And as mentioned earlier, the next SGP meeting will take place on March 4th, 2026 from 1 to 4 in Oakland. And information regarding options for attending the meeting will be made available closer to the March meeting date. But thank you to the panel and audience, and the meeting is adjourned.